All right, AQR students, we're back doing some math instead of the Fermi stuff. Fermi stuff is math, but anyway, you know what I mean. So today's question that we're going to tackle is, will we ever run out of telephone numbers? With the advent of cell phones and all sorts of other telecommunication equipment, lots and lots and lots of telephone numbers are being used. This was not an issue when I was growing up, but it definitely is an issue now. So, let's look at what we've got here. During the past few years, there have been several statements of the form, it is conceivable that we may run out of area codes and telephone numbers within the next 10 years. The shortage of phone numbers is due to the proliferating use of cell phones, pagers, and fax machines. And I'll just tell you that this stuff is written about 10 years ago. You can see down at the bottom of the page, if you printed this out, you'll see that it was made in 2010. In the next few problems, you will estimate the number of possible telephone numbers in North America. The assignment of telephone numbers is coordinated by the North American Numbering Plan Administration, www.nanpa.com. NANPA actually covers only the United States and its territories, Canada, and the Caribbean. Mexico is not included in NANPA. So, a telephone number in the form NYZ-ABC-XXXX has three sections. You've got the area code NYZ, you've got the exchange code ABC, and the station code XXXX. Before 1995, all area codes had the form NYZ. And notice this is before 1995, because that's our first question is going to deal with this. All area codes had the form NYZ, where N was any digit from 2 to 9, Y was either 0 or 1, Z was 1 to 9 if Y was 0, and Z was 2 to 9 if Y was 1. Okay, so we had two different situations there. The restrictions on N saved 0 for call operator and 1 for long distance calls. Always before 1995, if you wanted to place a long distance call, you dialed 1, then the area code, then the number. So, and back then, before 1995, Waco was not 254. Waco was lumped together with Fort Worth, and we were 817. I grew up in San Antonio, which San Antonio and Austin shared 512. Now Austin is 512, but San Antonio has a different area code from that. Where was I? So the restriction that Y is equal to 0 or 1 was removed in 1995 because all possible area codes had been assigned. Today, N is 2 through 9. I don't know if this was on the part I'm reading. Today, N is 2 through 9, Y is 0 through 8, Z is 0 through 9. The exception to these rules are codes of the form 37Z and 96Z, which are being reserved for future use. Area codes where Y equals Z are called easily recognizable codes and are often assigned to special services such as 800 and 877. So the first question here is, how many area codes were possible before 1995? All right. How many area codes possible before 1995? I don't have a whole lot of room to work here, so I'm going to do my work on a different page. So for number 1 here, I know what I'm looking for is area codes before 1995. They had the form NYZ. So if Y is 0, okay, if Y is 0, then my N value can be from 2 to 9. This number is somewhere between 2 to 9. And Z, if Y is 0, can be between 1 and 9. So I've got from 2 to 9, that is 8 different digits. I have 8 different digits here. I only have one choice here for my Y, and then I've got 9 different numbers for my Z. And so that gives me 72 choices there if Y is 0. My other situation would be if Y is equal to 1. If Y is equal to 1, N is still going to be some number between 2 and 9, but now Z is also 2 to 9 instead of 1 to 9. All right, so I've got 8 choices. Y, there's no choice, it's a 1, and then 8 choices for the Z, so 64 there. And if I add those two together, 72 plus 64, I get 136 different area codes. So prior to 1995, that's what we had. We had 136 area codes. That was it. Okay? Number 2 says, according to post-1995, so after 1995 rules, how many area codes are possible today? All right. So now I've got NYZ. Okay. My N is between 2 and 9. My Y is between 0 and 8. And my Z value is between 0 and 9. Okay? If we multiply those together, I get 8 choices for my N. I have 9 choices from 0 to 8. That is 9 different digits for my Y. I have 10 choices for my Z. 0 to 9, that is 10 different digits. All right, but we have some that are excluded. Remember that there are 2. There's the 37Z and 96Z, which are excluded. Those are being saved. So that would be 10. I can make 10 different area codes from 370, 371, 372, all the way up to 379. So that's 10 area codes. 960, 961, 962, all the way up to 969. That's 10 area codes. So there's 20 that are being set aside that we're not going to be able to use. And so this is 8 times 9 is 72, times 10 is 720, minus 20. We have 700 area codes now. So that is a significant jump up over 136 area codes. Okay, we've gone from 136 to 700 in one fell swoop. All right. Number 3. The 7-digit numbers in a given area code have the form ABC XXXX, where X, B, and C, X, B, and C can be any digit from 0 to 9. A is restricted to 2 to 9. 2 other restrictions here. B and C, those 2 letters right after the A, cannot both equal 1. So you can't have, for example, you don't want to have 911 here or something, all right? It can't be 311, 411, 511. And since these values are designated for other purposes such as 911 and 411, and 555-0100 through 555-0199 are reserved for fictional uses such as in television shows or movies. So according to these conditions, how many 7-digit numbers are possible in a single area code? All right. So this is number 3 we're looking at, and we're doing A, B, C, X, 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 X. Okay? So, for the A, it is somewhere, we're going to use the numbers 2 through 9 there, so that is 8 different choices. For B and C, B and C can be 0 to 9. C is also 0 to 9. So I've got 10 choices there. All right, so times 10, times 10. And then all these X's, all of those can also be 0 to 9. So I'm going to have 4 more 10s here. All right, so this is 8 times 10 to the 6th power. All right, that's actually 8 million here, 8 million phone. So, but we have some restrictions, right? Okay, we are going to subtract off minus, what do we have here? So there are going to be how many, so I've got restricting, if I'm going to take off anything that's like something 1-1, A11, XXXX, okay? So A, again, is still going to have 8 choices. Only no choice really for the B or the C because those have to be 1s. And then XXXX, that's going to be 10 times 10 times 10 times 10. All right. So now I've got 8 times 10 to the 6th minus 8 times 10 to the 4th. And then I've got one other restriction that I need to take care of here, and that's going to be my fictional numbers. The 555, 0100, 555, 0100 through 555, 0199. So that's actually 100 different phone numbers, minus 100 here. There's 100 made up numbers that they use for movies and TV shows. All right, so let's use a calculator here to figure out what this is. I've got 8 times 10 to the 6th power minus 8 times 10 to the 4th power minus 100. And I'm getting, oops, I made a mistake there. Sorry about that. Let's try that again. 8 times 10 to the 6th minus 8 times 10 to the 4th minus 100. Let's see if that looks better. Yeah. And I'm getting that this is 7,919,900 different phone numbers inside each area code. All right, 7,919,900 phone numbers inside each area code. All right, number 4 then. Let's look at number 4. 4 says, find it. Using your answers to the previous questions, determine how many 10-digit numbers are possible in North America. Okay, so we have 700 area codes. We have, for each area code, we have 7,919,900 phone numbers. So if we multiply those together, I get, let me see if I can figure out what this is. This is 5,543,930,000 phone numbers available. Okay, 5,543,900. Excuse me, 5,543,930,000 different phone numbers. Okay, this is an upper estimate. There are other restrictions, but this gives us probably a pretty good estimate. All right. Next problem, number 5 here is an extension. This is what I'm going to ask you to do. I'm going to ask you to do 5A through E, and I'm going to put that as your practice problem to turn in. Okay? But it's about license plate numbers. So I'm just going to read through it very, very quickly. Some states are running out of license plate numbers. Delaware currently uses 6-digit numbers in its license plate numbering system, although recent reports show that its numbers are approaching 1 million. Delaware uses retired numbers for new cars in many cases. The state of Washington recently stated that it needs to explore options in its system of 3 numerical digits followed by 3 letters because it is running out of numbers. New Jersey changed its system of 3 letters followed by 2 numerical digits and 1 letter to a new system of 1 letter, 2 numerical digits, and 3 letters. The last number under the old system was ZZZ99Z, and then followed by A10AAA in the new system. So, your question is going to be all about New Jersey here. How could you determine how many plate numbers New Jersey was able to assign under the previous system? And what assumptions did you make in your calculation? Part B, how many additional license plate numbers can New Jersey assign under the new numbering system? C, why do you think the first license plate under the new system was not A00AAA? D, how do New Jersey's previous and new systems relate to the license plate numbering systems used in Delaware and Washington? And finally, E, what do license plate numbers tell you about the population in the state? Okay? Let me know if you have any questions or comments, and I will talk to y'all tomorrow.